Good afternoon, everybody, or good morning, I should say, and thank you for joining us today. The CPD presentation, as you can see, is entitled Delivering Flexibility and Control to Commercial Lighting Solutions, and is brought to you by Legrand Electric Limited and Voltimum. My name is Matt Crunden. I'm the Training and BIM Manager for Legrand. I've got Wayne with me today. Wayne, could I ask you to introduce yourself to our audience, please?
Yeah, thanks, Matt. Yes, my name's Wayne Brewerton. I'm a business development manager working within the power distribution business unit of Legrand. And generally, I look after everything that you would think of the Electrac brand, but not the traditional underfloor type systems, more of the kit that you haven't heard of that's installed above the ceiling. So, yeah, thanks, Matt. That's what I do.
Okay, so Legrand in the UK very quickly is structured into 6 business units, and it's powered by specialist teams within those business units. And you can see them here on the screen, from assisted living and healthcare, cable management, digital infrastructures, energy controls, power distribution, which is really what we're talking about today, and wiring devices.
Okay, well, today's CPD accounts for an hour's CPD accredited by CPD themselves, so it can be registered against any professional institution's requirements. And this is available to be taken as a webinar or on the road by ourselves from the Legrand's Power Distribution Business Unit. And it also includes a section about building information modeling, BIM software, that we have the Revit components ready for download directly from our website, so we just thought we'd make everybody aware of that fact as well. Yeah, Matt.
Excellent. So as Wayne's just said, we'll talk about BIM a little bit later, just a handful of slides on that. But in essence, it's all about the digitization of our industry. So imagine, quite simply on the screen here, you needed to design the facility on the bottom left. Traditionally, we would do thousands upon thousands of 2D drawings, but let's try and move everything into the digital environment, and we'll do things in a 3D computerized environment. So quite simply that's what we're trying to do. We'll touch on that a little bit later. So after that brief introduction to ourselves and to Legrand, now on to the CPD seminar itself. So by the end of the seminar, we would expect that the participants, you guys out there, will have gained an understanding of commercial lighting systems, specifically reviewing lighting system options, which will include lighting installations, lighting adaptability and upgrading, lighting control, Dolly, which is digital lighting control, and a little bit about building information modeling. As Wayne's already alluded to, the webinar's fully approved for CPD purposes. Attendance certificates will be made available after the event within 2 working weeks or 10 working days. There will also be an opportunity to download the presentation at the end. We'll point that out when the time comes. So here's the agenda. I'm not going to read through all of that for you, but you can see we'll be talking about quite a broad number of subjects within the seminar itself. Beginning with a simple question, which I'm going to pose to Wayne. So Wayne, what do we want from a lighting installation?
Okay, right. To start from the very basics, and apologies go out to experienced electrical engineers and designers, but we start from the basics because there are non-electrical people logging into this seminar. So for the basics, what do we have to do? Well, of course, we have to provide a means of distributing energy, power from the distribution or the point of use. So we have to provide some means of wiring. So on top of the wiring, what we also have to do as an absolute minimum is provide a means of controlling that energy flow, basically to comply with building regs, and the 6 meter rule. So we have to, within 6 meters of where a person is occupying that space, we have to provide either a simple sensor or a switch to energize and de-energize the luminaires, the group of luminaires.
Okay, so that's quite simply, Wayne, it's power and control. But obviously there's much more in terms of the possibilities that we can look at. So could you tell me what else a lighting installation could do?
So behind the lighting installation, the system of wiring and control and connection, we can either do something very simply, so single circuit control, or we can have some kind of network system that allows the lighting control system, lighting power distribution system to be reconfigured. Yeah, so it can either be a very simple level of reconfiguration, so we're just going to change a switch group from a certain sensor to a certain circuit, or it might be a system that allows an entire floor to be completely reconfigured with the minimum of wiring and say hard electrical work, there's soft ways of controlling, digital ways of controlling things.
Okay, so we're talking full flexibility and the ability to reconfigure as two key themes.
Yes.
Excellent. Okay, so let's take a look at some of the options which are available to us for commercial lighting systems. So here we're going to look at different types, some of the issues for each type, but also some cost implications. So if we can cover those, beginning with some types, if we can.
So up on the screen there, everybody will see we detailed three options. Not all of the options, but three typical options that we can look at for providing power and control behind a lighting installation. So the first one, the traditional way of doing things, is with cable and containment. So it could be some kind of cable sitting on a cable tray or a basket, or more traditionally, it's probably single core LSF or smoke zero halogen type cables contained within a cable trunking and conduit, and those cable trunkers and conduits branch off to junction boxes or some kind of distribution box to which those single core cables will be terminated in and distributed to the lighting fittings, the luminaires themselves, normally by like a heat resistant flex from a plug-in cylinder or something like that, or a junction box, which is shown on there. Okay, the second one, we'll talk about prefabricated cabling systems, or what they're more commonly known in the industry as modular wiring systems.
Mm-hmm.
So what you have there is the modular wiring system. The box that's shown on figure 2 is a distribution box, and the metallic system that you can see running away from there is a flexible conduit which contains a number of circuits and communications bus circuits for controls, and they are wired back to the distribution board. Circuits are terminated individually. The third one are Buzzbar trunking systems, which is more of the type of systems that we as a business manufacture. And Buzzbar trunking systems, for anybody that doesn't understand what they are the pre-manufactured lengths of metal extrusion, which contain within a number of conductors, and the conductors are solid copper or aluminium bar, buzz bars. Those pre-manufactured lengths plugged together, so the manufactured in a factory, and generally it's just lengths of pre-wired trunking, pre-manufactured trunking, which plug together, and the power and control points, or the control buses, depending what they are accessed at regular intervals by a plugging what we call tap-off unit, at points throughout the system.
Okay, so that briefly covers the three options in terms of the types. So let's have a look at some of the issues, or some of the characteristics, perhaps, let's say, associated with those three different sys types.
Okay, so your cable and containment systems, so whether that be singles and conduit trunk and twin and earth on basket, whatever it might be, you're going to end up from the very start with a high number of circuits, because you have a limited number of luminaires that you can supply with one circuit. Obviously, with LED lighting and what have you, there's less current draw involved these days, but you still want to keep your circuits. Any designer would want to keep the circuits down to a number, typically 8 to 10 luminaires, which brings me on to point 2, small number of light fittings per circuit. The very characteristics and nature of hardwired cable and containment type systems mean there are many electrical terminations on site. So that has an effect on testing and inspection, obviously, when we get to the commissioning stage. But out of the three, without a doubt, the number one has the lowest material outlay. But conversely, it has the highest the highest installation cost, because you're buying a load of kit, which is generally commodity product off a wholesaler's shelf, but it's labor intensive to put it all together and fit on site, and consequently, because of the nature of that type of system, you end up with a completely fixed system where, well, any adaptations to it's going to involve rewiring.
Okay, understood.
Okay, yeah, prefabricated cabling systems, modular wiring systems, obviously, because a lot of the work's done off-site in a factory, that is going to increase the manufacturing cost of the kit. It's not commodity product anymore. It's made to order. But your installation cost starts to drop, because obviously a lot of the work is done off-site, and it's a case of bringing the modular wiring system, the prefabricated system to site, ready measured, and fitting. I mean, the installation costs dropping, but we still do require some kind of secondary containment for what we call the home run. That's never just going to be laid on top of the ceiling grid. It's going to be at least in some kind of basket type system on a cable tray. Configurations, or it has to be designed properly. We don't want stuff or the kit to come to site and find that we're going to have obstructions. So this is where BIM comes into things,
Yeah, absolutely.
But it has to be designed, it has to be fit for the purpose, But spare capacity can be designed into these systems, so you can have adaptations, modifications, require less of the, I hate to use the term plug and play, but it seems to be an accepted term to use these days, so you can plug new kit in, and you design spare circuits in for fit outs and what have you. Okay, so the third system that we'll look at are Buzzbar trunking systems. So you definitely require the fewest circuits for these, because effectively you're taking your distribution board, your distribution system into the ceiling void or wherever it's mounted. Material outlay, I don't know whether it is the highest. I mean, between 2 and 3, it depends on the project. Certainly 2 can be higher at sometimes, 3 can be higher at sometimes. But what we can say without a doubt is it definitely has the lowest installation cost. If you can imagine, if you compare 3 with 1, your Buzzbar trunking's in the same time as you put your trunking in before you even start to prepare it for wiring.
Right, okay.
Compared with 2, your Buzzbar trunking system's in the same time as your basket for your home run is in, so that hopefully that gives the audience some kind of idea what we're talking about with the installation time. Spare capacity obviously is designed throughout the system. Buzzbar trunking systems by their nature have sockets every 300, 500,000 mil, whatever it is, so, and they're never, they're always designed to accommodate, to leave spare capacity for future mods. Okay, so yeah, thanks.
Excellent. So you briefly mentioned material outlay versus installation cost for all three of those system types there. Could you just expand a little on that for a moment, Wayne?
Okay, yeah, well, I kind of covered it already, but we'll talk about it again. The materials versus labor element. When you're looking at go back to option 1, when you're looking at a load of kits that you have to buy from whatever source of supply it's coming from, it arrives on site. it's not measured, you know, chunking conduit systems, you know, if you look at any typical work that an electrician has to do, chunking has to be cut to the right dimensions, it has to be prepared, conduit systems have to be, you know, galvanized conduit has to be bent into shape, you know, with the specialist conduit bending kit, you know, and threaded, you know, and you know, it's very, very labor intensive. It's very, very slow, and this is before you even start to pull cables through. When you take some of the when you take a lot of that labor intensive stuff away from site and it's done in a factory, you know, with modular wiring systems and with busbar trunking systems, obviously these things come designed ready for the purpose that they're going to be installed for, and the labor element starts to minimize. You know, we're talking about typically I get quoted figures back, not so much with modular wiring because I don't get involved with that. It's not our product. It's not in our product range. But busbar trunking systems contractors are up to 75, 80% even labor savings with that type of system.
Okay.
You know,
So if we considered whole life cycle costs,
yeah.
for example, instead of just the installation phase itself, if we consider that, then thinking of the cost implications of those terms could then sway the balance towards a prefabricated system. If we talk about whole life cycle costs.
Absolutely. When you're talking about whole life cycle costs, with option one, typically the best thing to consider is a speculative office development. Right, these buildings are built, you know, and you know we'll touch on it a little bit more in further on in the presentation, but they're built and they have a lighting system in to provide, I don't know, 450, 500 lux, and the control, there'll be lighting controls behind it as well, you know, but it's the basic control to cover the building regs. Now, if you've got option one in the system and and the architects decided, or the interior designer, the interior fit out company, whoever that might be, they've decided that they're going to have a load of partitions, a load of meeting rooms in, etc. With option one, I mean, it's a rewiring job without a doubt. With option two and option three, you have the facilities there to quickly modify the existing system to cater for the new layout, and that's got an obvious knock-on effect on life cycle costs. You know, where a client may be concerned, you know, and the lettability of the building. But I think we'll cover a little bit more of that as we progress.
That's fine. Perfect. Perfect. Okay, so let's do exactly that way, and we'll take a little focus on upgrading and changing lighting systems. We'll talk through each of these in turn, with traditional cable and containment kicking us off in this particular section.
Okay. So a traditional cable and containment system. What is the installation methods? Well, first of all, we're looking here at a single core LSF insulated installation within cable trunking and conduit. So first of all, what has to happen is the trunking systems have to be cut to size, and there might have to be some site manufactured tees and bends, that sort of thing, before we even start to install. Right. Then before we even start to pull cables, those systems need to be prepared. We need to make sure that there are no rough edges within the trunking system that could possibly start a strip installation when the electricians start to pull the cables. So then the cables can be pulled in and wired, cables terminated. Control, it's certainly not always the case, but normally with a traditional type system, your control is going to be like fire switches, sensors, you know, either comply with the building regs. Obviously, the building regs encourage automatic controls, but it would tend to be local control just within the circuit, going right back to the first point that we made in this presentation. Limited adaptability, we've talked about that, you know, when if that floor area there was to be rewired, was to be fitted out and partitioned, there'd be a considerable rewiring job needed. No continuity of service. What we're saying there is, with the modular and the Buzzbar type systems, if there was a small area of that floor plate needed to be reconfigured or rewired, it can be done while the system's live, you know. So people bearing the disruption in the area, you know, if that was acceptable, you know, wouldn't have to decant that whole floor. With a traditional type system, you know, really would have to isolate that whole distribution board and log it off, you know, because the chances of wiring become live. And again, high number of circuits. The smaller circuits, higher number of circuits, that's going to increase pressure on the switchgear. And I don't mean that by power, you know, power requirement, but you're going to need more into circuit breakers, RCDs, whatever's the designer is required for protection of the circuit.
Okay, and a prefab system, how would that differ?
Okay, so modular wiring, prefabricated modular wiring. What we can see on the picture, the drawing that's in front of us now is a modular wiring system. So you have, I think the best way, there's green boxes with a like a cross symbol, two of them in the center, and they are the MDBs, the main distribution boxes. So from the main distribution boxes, we have a black line and a green line running back to the black line runs back to the distribution board. Green line runs back to, in the case of a lighting control system, let's call it an area control unit, and the green line is the bus cable, the controls cable. So with it, the black line signifies the home run in the modular wiring system, and what the home run is say those boxes are 6 boxes, so that has 18 single core cables,
Okay.
right, that run back to the distribution board, and each one needs to be terminated as its own circuit, so 3 per circuit, live, neutral, and earth. Then those MDBs, the modular distribution boxes, from there are, if we consider the blue dotted lines that go to the lighting control modules, the lighting control boxes, they're a further armored system. So they probably have, you know, it's probably single core cables wrapped in some kind of metallic flexible conduit with a connector either side. So there'll be live, neutral, and earth within there, plus the bus cable for wherever that bus system may be, you know, KNX, Modbus, Dolly, Lonworks, whatever it is, and then that connects to the lighting control modules, the little blue boxes, which we'll say this is a network lighting control system. They are feeding the luminaires and controlling the luminaires individually, and also taking in the control signals from the sensors. Okay, so obviously that is a modular, rapidly installed system, which, you know, designed properly, will have plenty of spare capacity to cater for future modifications. Okay.
Okay, and then we have the third system, which is the Buzzbar installation.
Okay. So there, in this example, we're looking at Buzzbar used in 3 different ways. So, you know, number one, we're looking at a Buzzbar trunking system. That particular Buzzbar trunking system's let's say it's a 3-phase Buzzbar, and we've got banks of luminaires controlled in the phases using old colors there, red, yellow, and blue. And those luminaires are controlled. Let's say it also contains a bus cable, and we're connecting sensors to the bus cable within that Buzzbar trunking. So say it's controlling contactors back to the distribution board via an intelligent sensor type system. Okay. Number 2, that's Buzzbar used in probably its simplest form. So what we have there is, let's just say it's a single phase Buzzbar, and it's feeding those the luminaires shown on there, and all it's doing is feeding power, live, neutral, and a CBC to those luminaires, and they each have their own individual controls. So it might be some kind of built-in sensors, built-in PIR, or it could be some kind of IoT device. So
Okay.
it could be networked, but on a Bluetooth mesh or a Wi-Fi type system, something like that. Then number three, Buzzbar, again used in quite a simple format. Let's say that number three, it doesn't show it on there, but say it's a dual circuit Buzzbar. So circuit one is feeding those distribution boxes that are available from all sorts of different manufacturers, but they're just a means of connecting power to the Buzzbar, then splitting it out over half a dozen circuits, and then maybe using on there we've got a sensor. So the sensor is a main sensor, just switching the luminaires via a loop-in method. Okay, and then, like I say, it's not shown on there, but typically what you would find with number three would probably be another circuit within that buzz bar, and we would be feeding fan coil units or TV screens. I'm just looking around this room here, Wi-Fi devices, or anything that's at high level that needs to get power, and it adds value again, because we're not having to run separate power supplies, ring circuits, radial circuits in for those items that have a small power requirement. Okay.
Okay. Just another system that we've touched upon, but probably not yet really explored, is an intelligent busbar system with integral communication. Could you just explain that to us quickly, Wayne?
Okay, so we can take busbar chunking systems a little step further. So what this example shows us is busbar chunking. Again, would say this is probably, although it's not shown there, a dual circuit busbar chunking. So circuit one is feeding within the busbars, feeding intelligent lighting control modules. Also within this busbar chunking system, we run a bus cable. So basically what that's doing is allowing us to distribute the power for the lighting and the comms for the lighting control, and also power for other devices, which we touched on briefly in the last slide. And we can add a little bit more value to that by introducing lighting control modules, such as are shown in the in the pictures at the bottom right, which use the busbar chunking itself as its proprietary means of support. So these particular lighting control modules have proprietary brackets on the back, and they can just clip to the busbar. So you can imagine, with other ways of installing lighting control modules, there's a whole system of perhaps even secondary steelwork to support them in the ceiling void. We can add value further by just utilizing the busbar chunking, and then just click, snap, plug in, and plugging that lighting control module into the busbar immediately gives us access to the power and the lighting controls bus. Very, very quick, very rapid.
Excellent. So, as I understand so far, the lighting control units snap on and plug into the busbar trunking. So that makes them very easy to reconfigure and or to reprogram if necessary, to accommodate any future lighting layout changes perhaps or additions. I've got that right?
That's correct, Matt.
Excellent. And then you can begin to accommodate presence detectors, absence detectors, scenario controls,
Absolutely.
all of that kind of thing, which is a big benefit to the client. Fantastic. So let's just look at a small case study. We'll look at upgrading an office lighting requirement from an existing to a proposed stage.
Yeah. Well, I think we touched briefly on this before, but the certainly in the case of the projects that I get involved in, it generally tends to be, it's not always the case, we put these sort of systems in all kinds of buildings, but the majority tends to be speculative office developments, so category A fit outs, which a developer which will construct, and then sell on to incoming tenants who are obviously going to want to change things, and put their own stamp on the building. So typically what's known in the industry is category A to category B. So if we can move on from that, we can look at typical ways we upgrade from Cat A to Cat B. So again, using the same example as we've used all the way through the presentation, we have an existing Category A layout and a proposed Category B layout. So Category A by the developer, Category B by the incoming tenant, and the incoming tenant changed the lighting somewhat, adding some perimeter lighting. There's a couple of cellular offices gone in there, and there's a couple of meeting rooms gone in there, and the sub-scenario controls and daylight linking, all kinds of lighting control added. Okay, so
Yeah, if that example was upgraded with a prefabricated cable system as we're showing here,
yeah,
how would that work?
well, the designer or the contractor, it depends on how the job was going to be progressed. The first thing that has to be assessed are there enough existing ways? Is there enough existing capacity within the modular wiring to cater for, on this example, we're showing lighting control modules for the new lighting, the additional lighting control modules to cater for the revised or the upgraded Cat B installation. So assuming that it was designed correctly in the first place, and there's plenty of spare capacity in there, the answer is yes. There's enough spare capacity in the MDBs. What then has to be assessed are what additional equipment's required, So again, going back to the blue dotted lines there, the armored connections within the modular wiring system, the devices that plug the plug, we have to purchase or procure those bits of kit and get them to site, purchase and procure the additional luminaires, the additional lighting controls devices. And because it's very simple, the modular wiring system, it all goes together, plugs together very easy. Then the lighting controls, people come along, commission the system, make it work, sign it off, and everybody's happy.
Okay.
Okay.
Using an intelligent Buzzbar system.
Using an intelligent Buzzbar, we again, as long as it's designed with the spare capacity in mind at Category A stage, it becomes even simpler because we know that we've got spare outlets at 300, 500,000, whatever the Buzzbar was specified in the first place to deliver down within the installation. So it's a case of just acquiring the control devices and the additional lighting control modules that are required, plugging them directly to the Buzzbar trunking system. There's no additional support. There's no additional wiring devices, if you like. It's just additional components.
It's as simple as that.
It's as simple as that. Of course, with any control system, there is a level of recommissioning, especially when we talk about Dolly Systems, which we're going to touch on a little bit later. But as far as the installation is concerned, it's very, very quick. And the commissioning side of it, well, if the installation's simpler, the commissioning's simpler.
Yeah.
Yeah.
Yeah. Understood. Fantastic. Perfect. Thank you, Wayne. Okay, so let's turn our attention to lighting control. Of course, we know that the demand for lighting control is growing, and we also know that lighting accounts for a high percentage of a commercial building's electricity use. The Lighting Industry Federation estimate that's about 40%, which is a significantly high number. So how can we offer some form of energy saving?
Right. Well, the easiest way to put it is if you have a building that, or an area that doesn't have any automatic lighting controls, and it relies completely on a human being hitting a switch when they leave the office, which we know, especially from where we are now, walk around of a night time, it doesn't happen, So if we have some kind of system that's in place to automatically turn the lighting off when there's nobody present, when it's not needed, the energy savings typically are in the region of between 30 and 55% over and above an installation or a building that that doesn't have that. It's human nature. And of course, lighting control systems, certainly not so much the hardware behind them, the Buzzbar trunking or the modular wiring or that sort of thing, but the electronic kit that does the clever stuff, of automatically switching things off, are 100% entitled to enhanced capital allowances, so that the VAT is fully reclaimable on those systems. And I have, it doesn't happen on every project, but I have been involved in projects where we ourselves don't get involved in doing that claim, but we get involved in providing the normally some kind of consultant that the client's employed after the building. We give them the information on how much it costs, and then they go back and I know of a couple of cases where it has been successfully reclaimed.
Okay.
So there's an edge there as well. So
yeah. And in terms of policymakers, we can see here from the slide that we've got on the screen here that there's a host of different global schemes or councils driving policies around energy efficiency, because that's a major thing for us these days. And of course, lighting control that we're talking about today plays a major part in energy saving. So let's just take a look at some of the main points. Building regulations make it very difficult these days to design buildings without lighting control. I think it's fair to say. We've got BREEAM and LEED ratings that clients and designers are very keen to make sure their buildings conform to those standards, and we'll take a look at those in a minute. We've got Dolly, and you'll explain Dolly to us a little bit later as we move through. Dolly lighting control protocol becoming effectively a standard for controlling energy efficient lighting. And we've mentioned BIM, building information modeling, once or twice today already. And as that further beds into the construction process, things like energy management and lighting control and properly being able to analyze the buildings that we want to build and the environment we want to construct will become more and more important as we look at whole life cycle costs across assets. So we'll skip over quickly some highlights of LEED, of BREEAM, and the WELL building standard, which we're beginning to see a little bit more these days as well. So 3 schemes here. LEED is a rating system devised by the United States Green Building Council that evaluates the environmental performance of a building, and it encourages market transformation towards sustainable designs. It's perhaps the most widely used green building rating system in the world. So LEED covers virtually all building, community and home project types, and it's based quite simply on a point system. The more points you earn, the higher your rating. BREEAM's probably the world's longest established method of assessing and rating and certifying sustainability of buildings. BREEAM recognizes and reflects the value in higher performing assets across the built environment life cycle through third-party certification. And then we've got the International WELL Building Institute, which is a public benefit corporation. And its aims are to improve human health and well-being in buildings and communities across the world through its WELL building standard. That was only launched in October 2014, so it's quite new compared to the other 2. But it's interesting because it focuses on 7 key themes across quality of air, quality of water, nourishment, fitness, comfort, mindfulness, and of course, lighting, which is what we're predominantly talking about today. So that's covering some of the schemes. But let's have a look at some different levels of lighting control. So we've got some different systems shown on the screen here. What can you tell us about these, Wayne?
Yeah, so the first 2, we have a non-intelligent system, so that is basically however it's wired, however the power is supplied and distributed. We're showing here the example of a Buzzbar trunking system, we basically have a means of getting power to near where it's actually required to be used, so that then it's distributed out through a dumb distribution box, which has a facility via a switch or a standalone sensing device to make or break power and control lighting. So then, second example, intelligent lighting controls, intelligent lighting control units. We have a system where we have busbar chunking, modular wiring, whatever it may be, that distributes the power and also the control signal to lighting control modules. And the lighting control modules themselves have a level of intelligence that can individually control luminaires. So switch on, dim up, dim down, and receive information from sensors, from devices in the field that influence that control.
Okay.
Okay. Then we'll talk about Dolly, and Dolly stands for Digital Addressable Lighting Interface. Now, basically what that is we, or the luminaire manufacturers, and more specifically the luminaire control gear manufacturers, I mean, it's been around for a good few years now, but it's become completely mainstream, have a device, an electronic control gear within the luminaire themselves, and that device is itself addressable and has a number. It can receive a number of commands, and it can also feed back a number of statuses to a lighting control system. Okay. Now, if we talk about the way we do systems, we have a busbar chunking system where we introduce a KNX bus using the bus pair within that busbar chunking system, and that KNX bus allows all of the devices on what we would call the backbone network, the KNX network, to be linked together. KNX is an open protocol which this product is available from. I think I've got information in front of me saying 300 manufacturers. I think it's near 450 manufacturers now that manufacture devices that seamlessly integrate on this KNX protocol. Okay. And there's tens of thousands of engineers, KNX certified engineers worldwide, that can work on these systems and recommission them and basically keep them running for clients. So with KNX, there's no manufacturer dependence. It's a completely open protocol. Okay.
Fine. So I was going to ask you what Dolly stood for, but you answered that one. Digital Addressable
Lighting Interface.
Excellent. So I think it's just worth mentioning, because you've talked about Dolly already as we've gone through. Yeah. It's worth mentioning that there is a technical standard, IEC 62386, that applies.
It is, yes. Dolly is a standard, so anything that we manufacture or any other control device manufacturer puts out onto the market, will, as long as we're compliant with that standard, which we are, of course, and I'm sure everybody else is, as long as it's compliant with that standard, we know it's seamlessly going to work with a luminaire that's manufactured or has control gear that also complies with that standard. And just to talk about Dolly Systems themselves, we kind of touched on it sort of briefly there, but if we can just jump back a slide, Matt, please.
We can do that. Yeah. Here we go. There we are.
Okay, so we've got two examples of Dolly Systems using Buzzbar shown on that slide. So the first one, or the top one, is what we would have there is a KNX bus running down the Buzzbar, and an LC. There's three LCMs shown there, but the center one shows itself. It's a Dolly domain or a Dolly subnetwork. So the KNX is the wide area network. the Dolly system, because you've only got a maximum. With Dolly 2, it's expanding a little bit, but with standard Dolly, you've got a maximum of 64 addresses or short addresses on each Dolly domain. So you'd imagine in a large installation, where there's many thousands of live fittings, we've done quite a few of these in the past. A single Dolly control system is insufficient for a full network building control or lighting control system. So we use KNX to link the Dolly domains together, or the Dolly subnetworks together. I'm showing another example there because we also getting, we've been involved particularly in airports. A lot of look at Heathrow, Gatwick, Aberdeen, Dublin, many airports around the UK, and quite a few abroad. We get involved with Dolly Systems, where we use the Buzzbar itself as a Dolly domain. So the Buzzbar distributes power, Dolly, and KNX. So KNX for the sensing devices to connect to the wider area network. Dolly, limited to 64 luminaires, of course, to connect the Dolly electronic control gear within each loop together, and obviously there's power in that buzz bar as well, and that's all marshaled back to some device that tends to live in the riser, or in the typical type airport sort of installations that I've mentioned there, because you don't have ceilings, and you have luminaires fitted directly to the buzz bar. If you imagine the big airport concourses and what have you, and you have a nice little connection straight from the buzz bar that takes the power and the control straight into the luminaire. I thought it was worth mentioning, So
definitely. Yeah. So my question is, the clients, Wayne, are they actually demanding Dolly?
Yeah, well, we find certainly on one of the big drivers for Dolly is, I think I touched on it before, is the fact that this digital addressable lighting not only can receive instructions from a lighting control system, so energize a lamp where dim up to a certain level, dim down to a certain level, and with Dolly too, change color, for human lighting and all that sort of technology that's emerging at the moment. We also, Dolly also has the facility to report back to the lighting control system, so that information can be harvested, so how long has that luminaire been on for, so we can calculate the energy that's being used, but particularly with emergency lighting, because Dolly electronic control gear that tests emergency lighting. I mean, you have like EM Pro, that's a Tridonic trade name, I know, and there's other emergency control gear available on the market, but that tends to be like the Hoover of it all, if you like.
Okay.
That kit will auto test, that can be scheduled to test emergency lighting. So that information on whether that particular bit of kit or that particular luminaire has passed a duration test or a functional test or failed, and why it might have failed, can be fed back into the lighting control system. Then it can be harvested. Generally, we use the term head end, head end's like a BMS term, but it's basically a web page, that tells the person responsible what the problem is, and that it needs to be fixed. So it sort of removes the sort of traditional way of testing emergency lighting of a guy walking around with his newspaper and a bunch of key switches on a Saturday morning. It's sitting there and watching for 3 hours. So clients are definitely asking, well, they have been for quite some time now, for this facility.
Excellent. Okay, so let's talk a little bit about building information modeling. Just a handful of slides here. So I've put a description here of BIM on the screen. There's many descriptions. BIM is a lot of different things to a lot of different people. But if we remember the 4 key points here that are shown in red, so what we're trying to do is create valuable collaboration between all players within the chain, from the client, the architect, the designer, the manufacturer, so that we can talk about the entire life cycles of the assets, not just that little build phase or the purchasing phase, whatever it might be. We want to talk about entire life cycles so that we can understand the full capabilities of what we're trying to do. And the way we can do that is with 2 approaches. But they're interlinked approaches. We've got the shared 3D models. So this is the 3D object side of things. and structured data. And quite simply, all structured data is data that's not presented in a haphazard way. So it's data that's been configured in a sensible manner that can become machine readable, so that we can analyze. For example, if you wanted to do a lighting analysis, if we've got data that we can easily understand and we can compare across different themes and different manufacturers, etc., we can use that data to the best of its ability. It's mandated in the by the UK government back in 2012. Section 2.32, you can see there, fully collaborative 3D BIM, and that was stipulated in the government construction strategy back in May 2011. The number of different savings that are expected from BIM, you can see there: lower costs, faster delivery of projects, lower emissions, and improvements in exports as well, all those types of things. So there's 4 key points, if you like, in red there. But what we really want to do is, if we can put quality data into a 3D environment, to the BIM model that we're building, quality data in means that we can export quality data at the end. If we put rubbish data in, we get rubbish data out. So it's really the most important factor really is probably the data, the information part of it. But just remember, quality data in, quality data out, employing 3D objects in an environment such as the one shown on the screen here. So instead of having thousands upon thousands of 2D drawings that we can misfile or lose or whatever it might be, everything's kept here contained within a shared environment that everybody can hook into and contribute to. And we put, remember, quality data in, quality data out. And that's really in a very quick handful of slides. I'm just conscious of the time we have left, what we're trying to achieve here. So look for structured data. Employ structured data in your models. There's some good 3D stuff in generic content, but also some good manufacturers content out there as well that you can use to do all of this stuff and do these lighting designs that we're talking about today. So moving quickly on, as I say, I'm just a little bit conscious of the time. We'll cover the regulations and standards in one slide, and I'm just going to show those to you here up on the screen. I'm not going to read through all of those, but you can see that Dolly is listed on there, KNX that Wayne was talking about earlier. Wiring regulations, the new wiring regulations 18th edition are due out in 2 weeks' time, I think on the 2nd of July. So look out for those when they come, because they come into official force, I think, the 1st of January 2019 or something like that. But they'll be out in a couple of weeks' time. So, conclusion, I'm going to ask you, Wayne, if you could give us a quick summary on what we've talked about today.
Yeah, absolutely. We would expect participants to have gained an understanding of what goes behind a lighting installation and see what is necessary to consider in terms of what to specify for what the system can achieve, you know. So it's not just a case of doing a quick and simple bit of fit out to just basically get the lighting on. It's a case of using the correct methods, the correct equipment, the correct protocols to allow that system to be modified and keep the costs down and keep the flexibility of the building going for as long as possible. Okay.
So whole life costs.
Absolutely.
In terms of product selection based on purely the cost of the product itself.
Yep.
So whole life cycle costs, as we've mentioned 2 or 3 times today. Okay, and of course we need to consider lighting control to assist energy saving,
Yes,
which is a
absolutely.
key theme in the environment at the moment, and forward plan. And if we do all of those things, then we should see a lot of benefits. Okay, so some further study and learning. There's a few websites on here that you can see: KNX website, Dali website, British Standards Institute, etc. And of course, you can pick up a lot of information from our own website, www.legrand.co.uk. So let's move to some questions and see if we can answer them. So, okay, there's a couple of questions coming here. The first one from Yasser. What about coordination when ceiling void space is limited? I guess option 2 would be the most suitable. So option 2 was the
option 2
prefab system.
prefabricated and modular wiring. Well, it depends. Obviously, Buzzbar trunking systems, you do need to have a zone, a nice clear zone to run the trunking systems through. Yep. So, I mean, even though we're not a manufacturer of modular wiring systems, there are times where it is more suitable than Buzzbar trunking systems. So, it depends. It depends completely on the building and the ceiling void space. Certainly, if you got a ceiling void of 50 millimeters, the Buzzbar trunking system's not your answer. But if in a modern office building where you have a nice, or any modern building where you have a nice clear zone, especially when you're using BIM to visualize what's going to happen there, Buzzbar trunking systems are possibly your answer. But yeah, every type of system, from certainly from my background as a designer, it's not one solution fits all. So yeah, absolutely.
Yeah,
So
perfect.
sometimes modular wiring is the best solution. Sometimes twin and earth's the best solution. It's obviously depends on the application.
Yeah, no, that's fine. Adrian's asking, what's the typical uplifting cost to introduce intelligent LCUs, DALI or KNX to a system? So most of Adrian's clients are cost concerned.
Yeah.
So what would the first choice be where perhaps cost is a constraint on a project?
Well, everything has a cost. Every device that you put into a system, if you have a simple distribution box, if that's what you're going to do, there's a cost associated with that. If you introduce intelligence with KNX and Dolly to it, you know what I mean? You could possibly, just plucking a figure out of the air. A very simple distribution box is going to be 50 or 60 pounds, right? An intelligent device that runs on a KNX backbone, and can handle 30 odd, 40 odd Dolly luminaires, a Dolly address is going to, be 150, 160 pounds, So there's obviously an uplift in cost, but there's also a benefit going forward with the increasing flexibility and actual control that you've got over the system. If you have a simple non-intelligent distribution box, that's fine and it's great for an application, but it's limited in how you can operate it. So all intelligent controls at cost, and if a client doesn't want that, if they want the basic of the basic, well, that's they use the basic of the basic, I guess it has to be accepted that intelligent controls don't. I'm not going to say they don't come cheap, because cheap's the wrong word. They don't add the costs that they used to years ago when I first got involved in this part of the industry from a manufacturing point of view. It's all a lot more competitive, and the manufacturers are more cost conscious, and obviously the volumes of the products that we make, control the costs a little bit, but all intelligent controls add cost.
Fine.
Can't
Okay.
avoid it.
John's asking an interesting question, John Bell. Is there a chance that a complete Dolly system can go down, which would perhaps be supplying a large building?
No, because with the likes of Dolly and KNX, the intelligence is distributed. So there isn't a central controller as such. All of these devices effectively have their own processes and function independently, but they are linked. So you can get devices go down, but it just tends to be limited to the problems localized rather than brings the whole thing down. That's not to say that if you had some kind of central controller that was putting signals into a system, say if you had a building that, let's put it in simple terms, had one device that turned the whole thing on and off, and it was a timer, and that timer failed to function. That's not to say that the lighting wouldn't be stuck in this whichever state it was in, but all these things have a power up. I mean, that doesn't happen anyway. You don't do that. But all of these devices, Dolly control gear, KNX control devices generally have a default of a power up on, or can be set to have a default of a power up on. So if you ever get a situation where the lighting is locked out for some kind of control failure, you generally just knock the breakers and switch them back on and get up and running, so that a building wouldn't become unoperational, until somebody could come and have a look at it. But intelligence in these systems is generally what we call distributed. So tends to be no reliance on one device or a central controller, for full functionality. If one bit goes down, the problem tends to be localized.
Okay, perfect. Fantastic. So I think that brings us to the end. Wayne, thank you ever so much for joining me today. I really appreciate it. And thank you to everybody for taking the time out to join us on the webinar today. And you can see there that there's a download just arrived on the screen where you can take a copy of the presentation. So yeah, thank you for joining us today.
Yep, thanks everybody. Thank you.